We're going to solve problems involving absolute value and inequalities. So here's our first problem. The absolute value of x is greater than or equal to 3. And what I suggest you do is you write this problem down and put some space to graph the problem. And I'm going to show you the other 5 problems that we're going to go over. And you should put some space and go ahead and copy those down. So here's the first one. Here's the second problem. The third problem. The fourth problem. The fifth problem. Okay, so there's just 5 problems. So maybe watch me do a couple of them and see if you can do the other problems, and then just check and see if you get the same answers. So this one is pretty easy. It says the absolute value of x is greater than or equal to 3. So I'm going to show you a couple ways to answer this. So whenever you have an absolute value equation or inequality, you always want to isolate the absolute value. So let's write that down. So we always isolate the absolute value. So here, the absolute value is the only thing on the left-hand side. So it is isolated, but if you have other things on the left-hand side, you want to move them over to the right-hand side so that the only thing you see is the absolute value signs. Now, this is what we're going to do. It's going to be very similar to when we have something like the absolute value of x is equal to 3. I'm going to have 2 equations. One is going to be x is greater than or equal to 3. We're going to keep the same sign. And then we're going to say x is less than or equal to negative 3. So we change. Now remember, before when we had an equals, we put x is equal to 3 and x is equal to negative 3. So you see how I have x and 3, x and negative 3. But this time, I keep the sign here when we keep the number, and then we flip the sign when we put the negative here. The other thing is, when you see this sign, you're going to say it out loud. It's a greater sign, so it's greater, but we're going to emphasize the or, because this, you're going to put the word or in between these two. So it's x is greater than or equal to 3, or x is less than or equal to negative 3. And then when we have a less than sign, we're going to say less than, and we're going to say and what we're going to write here is and. So when we have greater, you're going to say greater, so I need to write or. Okay, so here's your solution. You have that x can be greater than or equal to 3, or x is less than or equal to negative 3. Let's check this. So let's put something greater than 3 into this inequality. So like 9. If we put 9 here, the absolute value of it is 9, and that is greater than or equal to 3. You can choose anything greater than or equal to 3, including 3, to plug in here, and you'll get a correct inequality here, a correct expression. So let's try something less than or equal to negative 3. So definitely if you put negative 3 in here, absolute value is 3, and that's greater than or equal to 3. Now choose something less than this, like negative 10. That's less than or equal to negative 3, and if you plug it into here, the absolute value of it is 10, and that's greater than or equal to 3. So I'm just double checking my work. Now this is the solution. I'm going to circle it like this, but I'm also going to write it in interval notation. Okay, so remember that interval notation, we use parentheses and brackets, and we always start with the smallest number x can be, and we work our way up to the biggest number. So notice that here I'm saying x can be less than or equal to negative 3. Maybe we should draw a number line to graph this. I'm going to put negative 3 here, and I'm going to put positive 3 here. So I can be less than or equal to negative 3. So I'm going to color in a circle here. When I color in the circle, that means I can equal this number, and I can be anything less than negative 3. And at the same time, I can be equal to 3 or bigger than it. So in interval notation, this would be anything from negative infinity. We go from negative infinity all the way to negative 3. We can equal negative 3, so we put a bracket, then union, bracket, 3 to positive infinity. So we go from the smallest to the largest without any jumps. Then we make a jump, and then we go from the smallest to the largest. And this word or is the same thing as this U or union sign here. Okay, so that's the solution to this problem. Now I want to graph this to give you another way to visualize this. This is going to be similar to what I did before when we had equal signs, so the last video I made. I'm going to think of this as a function. This is f of x, and think of this function as g of x. Let's graph this function. Now this is a parent function that we learned. Just make some dots like this. Okay, this is f. And then g is just a straight line. It's a line at y is equal to 3. So here's 3. If I graph this. Okay. Now before, if we said that this was equal to 3, we would just look and see the 2 points that these two curves intersect. But now we want all the values for when this function is bigger than 3. So if this is 3, and we can continue this out this way and this way, anytime we're bigger than 3 is up here. Notice that all the y values, if this is 3, we're bigger than 3 for our y values when we're above this green line. And we're below 3 when we're below this green line. And we're equal to 3 when we're on this green line. So I'm going to shade this region, including the line, because we can equal 3. So that is when we're greater than or equal to 3. So what I'm asking you here is, for what x values is my black graph in this red area? And you can see that because this goes on forever this way, and this side goes on forever this way, from negative infinity all the way to right here, at 3, the line is going to be above or on this, in this red area. Then from negative 3 to positive 3, your graph here, the black graph, is below this red area. And then from 3 to infinity, just like we wrote here, from 3 to infinity, you're going to be above. So that's another way to visualize this graph and to visualize this answer. Let's try another problem. Here I have the absolute value of 2x is greater than 6. Again, I'm going to do it 2 ways just so that you can see both, but you really only have to do it one way, and you just choose the way that works best for you. But on your homework, you might see some graphs, so you want to be familiar with both ways. Okay, here I have the absolute value of 2x is greater than 6. First thing I do is I isolate the absolute value. The absolute value is by itself on this side, so there's nothing I need to do there. Then we say, okay, 2x, and then I put 6, and 2x, and negative 6. Before, when we had equal sign, we would just put equal here and equal here, but what I'm going to do is I'm going to put a greater than sign here and a less than sign. And I'm going to say, oh, this is a greater sign, so I'm going to put the word or here. Okay, now let's solve for x, so divide both sides by 2. And I have x is greater than 3, or x is less than negative 3. This is very similar to the last problem. So let's draw a number line. Now you don't have to draw a number line, but this is helpful to make sure you get the interval notation correct. We're saying x is greater than 3, so we're not going to be equal to 3. We're going to go to infinity, and we can be less than negative 3. Like that. So then in interval notation, we go from negative infinity to -3. We put a parenthesis on -3 because we can't equal it. 3 to infinity. And that's the solution. Okay, now I want to graph this, just so we have another way to see this. So again, we're going to let this black graph be f of x, and then we're going to do a green graph, which will be g of x. G of x is easy to graph. Let's go ahead and do that. So here's g, the function right here, 6, is just a straight line. And then 2x. So let's think about this. The absolute value of 2x. The parent function, I'm going to define it as f1 of x. We know what this parent function looks like. Let's draw some points. In fact, I'm just going to put points. I'm not going to draw the graph. You can do a dotted line, or you can draw the whole graph if you want to, but we're going to erase it because this is not the function we want. This is the parent function. So this is the absolute value of x. Now, how do I go from the absolute value of x to 2x in the inside? Well, what I do is I plug in, I'm going to define a new function, and that function is where we plug in 2x into this function. So that is the absolute value of 2 times x. Now recall what that does. Now this is the function we want. This is f of x. In fact, you don't even have to call this f2x. You can just say f of x is when we plug in 2 times x into this function here. So remember that when we put a number on the inside of the function, if it's larger than 1, then I think it compresses the graph, if you remember that. It pushes the graph inward. And what I like to do with things like this, because that's a little difficult to understand mentally, all I know is it's going to push this graph in. That's what I should expect. So what I would do is I would choose x values. Like here on the original graph, we had 0, 0. And since that's right on the axis, it's not going anywhere. But let's go with this point here. So this is when x is 1, and this value is 1, 1. So if we plug 1 into the function, what do we get? So if this is our function, f of 1 is 2 times 1, which is 2. So this point now moves here. So you can see that it multiplied the y value by 2, or you could think of it as halving this x value. Because 1/2, if you plug in 1/2, it will go to where we originally were, which was 1. See this point? You could think of this point moving this way or moving up. Let's try this point here. This point is 2, 2. That's originally on the absolute value. And if you plug in 2 into the new function that we have, we're going to get 4. So 2 is now moved to 4. Let's try this point here. This is 3, 3. And now you can see what's going to happen. Your y value is going to be multiplied by 2, so it's going to go to 6. Just plug 3 into here, you see you'll get the absolute value of 6. Because this graph is symmetric, you're going to have the same thing on the other side. So you're going to have the same y values, and the x values are going to be multiplied by negative. Okay, now we have our graph. And now let's think about what we're looking for. We want to know when our blue graph here, when is it bigger, the y value is bigger than 6. So if this is 6, we're looking for when we're above this line. And that happens to be, you can see that when we're equal to -3 or 3, we're actually on the line. But from -infinity to -3, we're above it. And then from -3 to 3, we're below the green line. And then from 3 to infinity, we're in the red area. So we get exactly the same answer by graphing. Okay, this is the third problem. We have the absolute value of x plus 4 plus 3 is less than 5. So again, we always want to isolate the absolute value. That's the first thing we should do. Notice that on the left-hand side of this, I have a plus 3. So the absolute value is not by itself. So let's move that over. Subtract 3 from both sides, we get 2. Okay, so now that we have less than, we're going to say x plus 4 is less than 2. Less than means we write the word and here. X plus 4 is greater than -2. Move the 4 to the other side, we get it x is less than -2, subtracting 4, and x is greater than -6. Let's put this on a number line. We have two important numbers here. -6 is on this side of -2. Put 0 down here if you want to. And then we have x is greater than -6. So I'm going to put this one like this. But at the same time, because we have the word and, we have to be less than -2. So the idea is when we have the word and, we have to look and see where these two intersect, where we're both blue and red at the same time. And that's right here. Notice that we're not blue and red on the endpoints, it's only in the middle. So the solution to this is from -6 to -2, that's the interval notation. And we put parentheses here because we can't be on the endpoints. Okay, now again, I'm going to show you the other way to find this. So we have our solution. So by graphing, we should get the same answer. We think of this as a function, f of x, and we think of this as a function, g of x. I'm going to graph g of x. That's the easier one to graph. Right at 5. Okay, so this piece is graphed. Now let's think about this one. This is taking the absolute value. Remember, your parent function is the absolute value. We have a plus 4 on the inside. So what happens to the absolute value? Well, we shift it to the left 4 units. And then we have a plus 3 on the outside of the absolute value, which means I shifted up 3 units. So I'm going to graph some points from the absolute value. Hopefully that will be enough points. And now what I'm going to do is I'm going to, because I have the plus 4 on the inside of the absolute value, I'm going to shift to the left 4 units. So let's see what I can do. I'm going to do this in a different color. So here's -2. This one goes over. Then our graph is going to look like this. Erase the original graph. And then the next step is to move the graph up 3 units. So this one moves up to here. Let's maybe do this one and I'll do this one in black again. So 3. Okay, now I can erase this blue graph. Oops. connect these dots. Recall what this is asking me to do. I'm trying to figure out when we're less than 5. So that means when are we below 5? Notice that this x value here is -6. This x value is -2. So you can see that from -infinity to -6, we're above. And then from -6 to -2, we're below. So we're in this red area. And then from -2 to infinity, we're above. And we are on the green line when we're on x is -6 and x is -2, but we want to be below the green line. So we don't include those two numbers, which is exactly what we got. Okay, here's problem number 4. Again, the first thing we want to do is isolate the absolute value. So we have 1 minus 2x, the absolute value of it, minus 4 is less than -1. So if I isolate, I get 1 minus 2x. Add 4 to both sides. So we get plus 4, this becomes 3. And then, because we have less than, we're going to say 1 minus 2x is less than 3, and, because less than, 1 minus 2x is greater than -3. Remember, switch the sign. Now solve for x, so I'm going to subtract 1. So I get -2x is less than 2. And on this side, I'm going to get -2x. So I subtract 1, I get is greater than -4. Okay, it might have been a while since you've seen this, but whenever you divide by a negative, when you have an inequality, you have to switch the sign. So when I divide both sides by -2, I'm going to get x. This will become -1, but this sign flips. Same thing here. -2, that becomes a +2, but we flip the sign. Now let's graph this. So we have a -1 and we have a +2. 1 point we have to be greater than -1. And at the same time, we have to be less than -2. So we just see where these two intersect, which is right here. So the solution to this is from -1 to 2 in interval notation. All right, this one's complicated to graph, and I wouldn't want you to graph this as the, I would prefer, I think it's easier for you to solve this problem in this method that I just did. Now, you can graph it and solve it in that method. It's just more complicated. Let's see what we can do. These answers, this -1 and 2, is something that's easy to plot, so maybe it's not too bad to graph it. It'll just give us a lot of practice. Okay, so we think of this as the function f of x, and this as the function g of x. -1 is right here. And then, okay, we got to ask ourselves a lot of questions. Now, this is something I would want to write out all the steps, because it's easy to make a mistake. So I start by defining a parent function. Maybe we can do this one in black. We'll say f1 of x is the parent function, absolute value of x. Okay. Okay, so that's the idea of what the graph looks like. I think I have enough points here, hopefully. This is the absolute value of x. Now we're going to define a new function, and we want to start doing changes to this function to make it look like this one. So something I could do is I could take care of this -4 first. So I could say, let's define this function as this one, subtract 4, and that will give me the absolute value of x minus 4. I mean, it's not exactly what I want, but I'm getting there. So I'm going to move everything down 4 units. 1, 2, 3, 4. So I have a bunch of points now. I erase the original graph. And I'm going to write here so I don't get confused that this is f2 of x. So this is the graph f2. And now I need to define a new function. Let's see what I can do. So I need to put 1 minus 2x into here. I think the first thing I'm going to do is I'm going to put, x plus 1 in. So I'm going to take f2 and plug in x plus 1. And you'll see, if you're not sure why I did that, you'll see in a minute why I did it. So this is going to be the absolute value of x plus 1 minus 4. So by doing this, I'm getting this 1, because this is the same thing as negative 2x plus 1. And then I want to plug in this negative 2 as the last piece. If you do the negative 2 first and then the plus 1, you're not going to get the right graph, because you're going to multiply that plus 1 by a negative 2 because you're plugging it in to the x. And that's not something you want to do. So I'm taking care of this left and right movement first. Because I'm plugging in 1 plus 1, that means I move to the left 1 unit. So let's do that. Okay, get rid of the blue one. Scared I'm going to erase the line. Okay, there we go. Okay, now we have F3. And now the last step is to plug in a negative 2x. You can plug in a 2 and then a negative if you want to, or you can do both at the same time. I think that's what I'm going to do. So F4 of x is, we're going to take this one, F3, and we're going to plug in a negative 2x. And that'll change this and give me what I want. A negative 2, so the negative in the inside refers to a reflection about the y-axis, and then the 2 stretches everything. I think the easiest thing to do here is just to plug in x values. That will help you. So let's see. I think we're going to do, let's go with blue. So we do a reflection. Let's do the reflection first. Oh, yeah, reflection. Like that. So remember, a negative on the inside. I'm not worried about the 2 right now. If I just put a negative, it's a reflection about the y-axis. So I'm just taking the mirror image of this. So and then we stretch everything by 2, or you can think of it compressing this way, or you can think of it pulling it up this way. Okay, so let's plug in some points. So the new function, this 1 minus 2x minus 4, this is f4. So if we plug in, let's say 0, what do we get? So if you plug in 0, you get absolute value of 1 minus 0 minus 4, which is 1 minus 4, which is negative 3, which is exactly what we have right here. So this point stays the same, 0, negative 3. Then if we go with, let's say, x is 1, if you plug 1 in here, let's try that. Let me erase this because I've got too much going on. If we plug in, actually, maybe I should keep that just because I need to check my answer. So let's erase this. And let's plug in 1. We get 1 minus 2 minus 4, which is 1 minus 4. So we plugged in a 1. This is negative 1, but it becomes 1 minus 4, which is negative 3. Okay. Interesting. Let's just keep going. And then if we plug in 2, I see what's happening. So if we plug in 2 into here, you get 1 minus 4, which becomes 3 minus 4, which is negative 1. So then we get the point 2 goes to negative 1, which is right here. And then we could plug in some more points if we want to. So if you plug in 3, you're going to get 1 minus 6, which is 5 minus 4, which is 1. So you're going to get a point right here. So what's happened here is actually we have a vertex at 1/2. So if you plug in 1/2, you get 1 minus 1, which is 0 minus 4, which is negative 4. So at 1/2, you have this vertex. And remember that this graph is symmetric. So then this point, this is at 1/2. So this is 2, 3, 1, 2, 3 right here. That's all we really need to know because we need to know when it intersects this green line. Okay, and then we need to figure out when we're less than negative 1. And you can see here is when x is negative 1, and here is when x is 2. So from negative 1 to 2, we're below this green line, just like we found before. This was really complicated. It even confused me to do it this way. I would not recommend graphing something like this. I would recommend using the first method to solve this one. Now, if you have something like this one, or even this one, or maybe this one for sure, these are easy to graph and figure out the solution. Now, again, your homework might show you graphs and ask you when is something greater than, so they might give you this graph here, and they might ask you, when is this function greater than this function? And then you would have to say, oh, from negative infinity to negative 3, and 3 to infinity, just because they want to test your knowledge of the graphs. Okay. But if I ask you to solve something like this, then you can just use the method I'm going to do for the last one, and what we did for the first method we did for all of these. You don't have to graph them. Now again, you can graph this one. I don't want to graph it. You can. You might notice that we have a negative on the outside. That's going to correspond to flipping this absolute value function upside down. So what you're going to have if you graph this, this is actually not too bad to graph, but you're going to have something like this. Because you have a negative on the outside of the absolute value, you have shifted what you can think of. I can graph it really quickly. So we're going to take the absolute value, we're going to flip it upside down. Then you have this plus 3. So you can shift the graph to the left 3. And then you have this 6 on the outside and you move it up 6. So that's how you could graph this function. Okay, but instead of doing that, what we're going to do is just do it algebraically. So we're going to isolate the absolute value. So let's move this 6 to the other side. So subtract 6. Minus 6 minus 6, this becomes a negative 4. Remember, when you move negatives, you don't change the sign. It's only when you multiply or divide by negatives. So here I have a negative on the outside, so we have to flip the sign. So we multiply everything by a negative. This becomes a positive, this becomes a positive, and then I flip this. Now we have a less than sign, so we have an x plus 3 is less than or equal to 4, and x plus 3 is greater than or equal to negative 4. Solve for x, subtract 3, subtract 3. Let's draw our number line. Put the smaller number over here, the bigger number here. This says we're less than or equal to 1. And we can equal this number so we can shade it in. And at the same time, we're greater than or equal to negative 7. Now we look and see where we shaded both, and notice that we included the endpoints. So the solution to this problem is from negative 7 to 1. That's the interval notation.